Hello everyone, my name is Madhu Sardi. I'm the Technical Marketing Engineer for Cisco Kinetic for Cities. Today I will briefly discuss how Cisco Kinetic for Cities address different challenges in domains like lighting, parking, urban mobility, and so on for smart cities. Cisco Kinetic for Cities is just not about technology or a Cisco platform. It's about how it improves the quality of life of citizens and how it provides better experience to the citizens. It also helps city managers or mayors provide real-time data and historical data on a single pane of glass. It also helps them to optimize city services. Kinetic for Cities in the background pulls the data from sensors cloud or sensors directly, normalizes the data, optimizes data as per data model, and feeds the data into data engines and the reference dashboard. The platform also provides northbound APIs so that application developers can pull the data from the Kinetic for Cities and feed the data into third-party applications and smartphone apps.
Lighting. About 38% of the energy used by the city is just on outdoor lighting. Now city wants to save the energy spent on this outdoor lighting so that it can reinvest the money in other domains. Kinetic for Cities gives the visibility and control of all the lights. It is agnostic to protocol, vendor, and technology. There is no need for independent management platform depending on protocol or vendor. Some lights have sensors which detect amount of sunlight and they can switch off automatically. And some sensors detect if there is no activity, they can switch off the light. And we can also schedule the control of lights using the policies. So all this contribute in terms of saving the energy spent on outdoor lighting. The light fixture, the light on top of the light fixtures, each node talk to the respective gateways over 6LoWPAN or Zigbee technologies. So we can go to the map view and select and hit on these three dots here. We'll get the drop down showing the domains deployed in the city. We'll select the lights here. So here the map view shows the lights deployed in the city. We can use the selection tool here to select a bunch of lights which gives the statistics of those lights. So in this case I selected 8 lights. Out of this we have 50 on and 50 off. We can also schedule the control of lights. Map view. So go to the map view. We can select the lighting by selecting one of the option here. You can see the light location. The map uses the latitude and longitude values from the GPS or from as part of the physical deployment. You can see the legends on the right hand side, which are very self-explanatory. We can use the selection tool here to select bunch of lights. In this case I'll select one light. It gives the statistics. Let me clear selection again and try again. here. Yeah, here it gives us the stats. I selected 8 lights. We can see all of them are off. You can also control the lights in real time by clicking on this change state button, and you can change the intensity and hit apply. You can also schedule the light controls by using the policies. For example, we already have a policy which is created, intensity 100. I can schedule it depending on the time. So current time is 6:45. I'll change it to 6:47. So this policy changes the light intensity to 100 every day after a certain time. So next and save. You can go back to the map view and select a light and click on the policies and events tab. And we can select the policy which we in the drop down, and we can just select apply. In this case we already applied it. We can see it here. Now at 6:47 we can see the light here will change to green. As you can see, now the light went to green. So by this way we can schedule the light control using the policies. Parking. About 30% of traffic congestion in cities is made by the citizens who are just looking for parking. One more data point. In cities like Paris, on an average, every citizen spends about 3 to 4 years of their lifespan just for looking parking. Through Cisco Kinetic for Cities, every parking activity is detected in real time via the in-ground sensors embedded in the parking bays or by the video cameras. This information can be sent to citizens in real time so that they can see the available parking and they can reserve it, and they can also get the directions to the exact location of the parking spot. This also helps in reducing the traffic congestion caused by the citizens who are just looking for the parking. Sensors use LoRaWAN or Zigbee technologies to talk to the respective gateways here. Parking. So we can see the parking deployment by selecting the option here. We can see the legends on the right hand side, which are more self-explanatory. The legend with P with square means it's a parking group. If you zoom into that, it gives it shows the parking spots. There are different types of parking. Demarcated parking, meaning parking spots which have clear boundary lines. Undemarcated, meaning parking spots which no clear boundaries. So here again we can use the selection tool and select group of parking spots which use the stats of those parking spots. Here I selected 9 and we get 100% availability. We can schedule the parking using the policies. For example, we can go to the policy tab. We have a existing one like a resort parking. We can schedule the parking type to be a resort parking after a certain time. For example, we can schedule a particular parking spot to a parking reserved parking. For example, in this case, every day we can change it to parking reserved parking. Let's say, for example, 19, 6, 7. So at 7:07, the parking spot now will change it to reserved parking. Going back to map view, we should go and apply the policy tab. Here, select the parking spot and hit the policy events button. In this case, I have already applied the reserved parking policy before the demo. We can select the policies created and using this drop down, and we can click apply. At that point it will apply the policy. So now at 7:07, this parking will change to reserved parking. As you can see, now it became to R. That means it became to reserved parking. Now that I showed parking and lighting demos, I'll show a demo on cross-domain event. Events are, I told you, I mentioned before, are cross-domain triggers. For example, here I created an event which changes the lighting whenever there is a parking spot becomes occupied, and whenever there is a parking spot unoccupied, the light changes to off. These are the two parking. The two events we will use it for the demo. I created them before the demo. Now that I showed lighting and parking demos, now I'll show cross-domain event, which basically triggers lighting depending on the parking activity. Event tab. So here I created a couple of events before. One of this parking occupied light means it will switch on the light when there is a parking spot changed to occupied. So here, whenever there's a parking spot status changes to occupied, we change the intensity of the light to 100% around 500 feet. Similarly, we created one more event which switch off the light when there is the parking spot becomes vacant. We can apply this on the parking spots. You can go to the map view. Let me also select lights. Here are the two parking spots. In the background, we are changing to, using the scripts, we are changing to occupied and unoccupied in regular intervals. Once you select, you can go to the policy events button and click the button here and go to the apply event tab. So in this case, I already applied the two events. If you have not applied, you can just go to this drop down and apply those events and hit apply. In this case, both the parking spots are unoccupied, the lights are switched off. If any one of them becomes occupied, the lights will switch on, and that means the lights will change to green. Now this parking went occupied. Now you can see the lights went on green. Urban mobility. The annual cost spent by each driver in US due to congestion is $1,400. Using urban mobility dashboard, cities can do traffic and crowd analysis. Using the historical reports, we can see the data and take some preventive actions to avoid traffic congestions. We are getting information from Meraki access points and Cisco CMX and analytics running on the camera for vehicle counts, type of vehicles, and the pedestrians walking by. In 3.1, we have traffic and mobility separately listed out, but in 4.1 onwards, under urban mobility, we will have traffic and mobility. So for this demo, I have selected both traffic and mobility. So using this dashboard, the city manager will know what is the traffic count and the direction. So here in this case, we have the traffic count, and we can get the direction also of the crowd. We can do mouse over and get the more details. You can get the vehicle count. We can also get the traffic. So here's the traffic currently on one particular street. We can mouse over it, and it gives what is the more details on the traffic. You can also get more details on like incident reports, like any accidents happen under any road under construction, or how is the congestion currently. We can click here, for example, and give the congestion also. Environment. Air quality, noise, and pollution are the issues which city wants to deal right away, as it impacts the economy of the city. For example, city of Copenhagen wants to be carbon neutral by 2025. Cities can enforce strict smog emission, and it can also reduce the number of vehicles, but it doesn't give quick results. Cities need robust platforms like Kinetic, which can get data from difficult areas. City can collect historical data, correlate the data, and take some corrective actions. For example, city can divert the traffic if it detects any hazardous gases in a particular area. At the same time, city can share this data to the citizens or businesses, etc. So we can see the environment information of the city by selecting the option here. We'll get the sensors deployed on the ground are sending different sensor data. Depending on the sensor, we get different values, CO2 and NO2. Some sensor give all the values, some sensor give only one or two values. Cities also can get the temperature of different areas or the light level also using the lux parameter. Here is the reference architecture which shows different Cisco products we use and the third-party sensors to deploy Cisco Kinetic for cities. I hope this helped you to understand how Cisco Kinetic for cities can help customers across the globe. For more resources, please refer to these links.